Jai Hind everyone, my name is Dr. Ayushi and I am professor here in Computer Science and Engineering Department at Akgec Engineering College. So today my topic is from the subject operating system and a topic that is CPU scheduling in OS I will be discussing today. So first of all, what is CPU scheduling? The basic concept of CPU scheduling, all the criterias of scheduling. On the basis of the criteria, different algorithms we will be discussing here, and then thread scheduling, and then multiprocessor scheduling, real-time CPU scheduling, operating systems examples, and algorithm evaluation. So half of I mean like 3 to 4 points would be discussing in the same video, and then again we would be discussing the remaining in the next video. So what are the objectives? So if anything we are going to do or discuss, so there must be some need and there must be some objective. Before discussing about the objective and need, we shouldn't proceed. So what is the objective? So introduce the CPU scheduling, which is the basis for multi-programming operating system. So when we want to do multi-programming, so that we get the maximum throughput, we can get the maximum response and maximum least waiting time. So we use some multi-programming, like and when we want to do multi-programming, so only with the help of CPU scheduling we can do this. So to describe various CPU scheduling algorithm is the objective of this PPT, and then to discuss the evaluation criteria for selecting a CPU scheduling algorithm for a particular system, to examine the scheduling algorithm of several operating systems. So we can see here when we are going to do CPU scheduling, I mean like CPU scheduling, when we are talking about CPU scheduling, it means we are going to scheduling it, the working of CPU, ordering of the working of CPU, which process will execute first and then next, second and then next, third and so on. So this is what we call the ordering of the CPU. So we do have many programs and we want to execute it one by one, right? Because we do have many programs that is ready in ready queue and waiting for the CPU to get executed. See, there is program and process. So when a static mode code is written there, the instructions what we have to do is program, and when CPU is allocated to that program, it will become in active mode and it will be processed. So this is the way by which any program can be changed in the process. So when we want to do process, we need CPU. So which one will come first, and then what is the next? So we need to know the scheduling, and for that we can say what is the possibility. So there is one CPU and it has to do many programming, multi-programming at a time. How is it possible? So the work of system is divided into two parts. One part is CPU and another part is input output work. So when the CPU is busy, so another program can do the input output work, and when the input output there is busy, the processor is scheduled to some other program. So we can say maximum CPU utilization obtained with the multi-programming, and this can be only possible when we do have CPU input output and burst cycle, CPU burst cycle and input output burst cycle. So we can see here, first we start with the CPU burst, in which the loads, add, store, read from file, and then wait for input output, and again for the CPU burst, and again for the input output burst, CPU burst, input output burst. So it is CPU followed by the input output burst, we can say, and there is a cycle of CPU and input output burst. And when one program is in its CPU burst, the another program, it can be in input output burst, and again the first one is in CPU, the next one is in input output burst. So by this way CPU scheduling is possible. So what is CPU scheduler? So when we are going to do scheduling of CPU, there must be some scheduler who will dispatch which program now CPU is allocated to which program. So CPU scheduler is basically we used to say short term scheduler, which selects from among the processes in ready queue and allocate the CPU to one of them. So there are many programs which is ready to execute. So out of all the programs, CPU allocate one program which is ready to execute, and then CPU is allocated to that particular program. So this work is done by CPU scheduler, and it is also known as short-term scheduler. CPU scheduler decided that which program has to choose in, and which program is going to take the CPU. So that depends upon few things, like the CPU scheduling decision may take place when a process switches from running to waiting state. So these are the decision may take place when. So this is the answer of when. So when it is switching from running to waiting state, or switching from running to ready state, or switching from waiting to ready, or terminate. So there are 4 conditions. So we have already read about the 5 states in which a process is start to execute. So it is in active mode, from there it is new, and then active, then new, from new it will be going into ready, and then it is going into running, and from running it again come into the waiting, and waiting to ready, and the final is the terminate. So switching we are reading here. So from where we can switch to which state, switching to a process, switching from which state to which state. So switching from running, so when a process is in running mode and another process, so there are 4 cases, switching from running to waiting state. So it is one process is in running, and due to some reason it will be going into waiting state. So this next is switching from running to ready. So one process is in running mode, and now again it is going into ready state. Switches from waiting to ready. One program is in waiting, and then now it is going into the ready. And then final, when there are 2 cases, when it has done its program, or another program is having higher priority, then it is there are 2 cases when it terminates. So scheduling under 1 and 4 is non-preemptive. Non-preemptive means when a process started its work, so it cannot be preempted before its completion. So it's non-preemptive. And 2 and 3 is preemptive. It means when a process is in running state, and due to some reason, priority of another program is high. So in that case, the CPU is taken from this running program and given to another. So this running program is in suspension, and when the current program completes its execution, then the running program, then the suspended program resume its work. So this is the case of 2, when it was in running, and due to the higher priority of other program, it is in ready state. So when the higher priority program will finish its work, then again it will come into the running state. Similarly, switches from waiting to ready is the same case, where it is in waiting state and it has completed its it has done its input output work, and it needs its CPU. So then it is coming to the ready. So all other scheduling is preemptive, considering access to shared data, considering preemption while in kernel mode, and considering interrupts occurring during crucial OS activities. So now what is dispatcher? I have already told dispatcher module gives control of the CPU to the process selected by the short-term scheduler or the CPU scheduler. So one process would be selected, and the CPU will be allocated to the selected. So who will decide? That is the CPU scheduler, and the dispatcher, it's only the module which give the control to the CPU to the process. So now if CPU will be allocated a process which has to run. Now this involves switching context, switching to the user mode, jumping to the proper location in the user program to restart that program. And the dispatch latency is the time it takes for dispatcher to stop one process and start another process. So it is just like we have process P1, process P2, process P3, process. So we do have 3 processes. So when P1 is, CPU is allocated to P1, right? And when P2 arrives having high priority than P1, so this CPU will be allocated to P2. P1 will go into suspended mode, and when P2 completes its work, then again P1 will, P2 completes its work, it will be terminated, and then P1 will, CPU will allocate it to P1. So this is the way by which the scheduling take place, and the dispatch latency is the time it takes for the dispatching to stop one process, means when it is doing switching context. So switching from one process, CPU switching from one process to another process, and from the second to third and third to fourth. So this is the time which it takes from switching from one process to start another program. So this is what we call dispatch latency. Now these are the different criteria by which you can decide which algorithm will be the better algorithm. So CPU utilization, the first thing is, for any system, the more you will be keeping the CPU busy is the best utilization of the CPU. And the throughput, we can say the process that complete their execution per unit time. Turnaround time is the amount to execute a particular process. Waiting time, amount of time a process has been waiting in the ready queue, right, to get the CPU. And response time is the amount of time it takes from when a request was submitted until the first response is produced, not output. First response, only when it will be getting the first response, the time in between is called the response time. So scheduling of algorithm optimizing criteria, we can say. So this is the, if you want to optimize, there should be maximum CPU utilization, maximum throughput, minimum turnaround time should be less, minimum waiting time, a process should wait minimum to get the CPU, and minimum response time, the first response should be as soon as possible. So this is the first algorithm. There are many algorithms like first come first serve, SGF, shortest job remaining first, priority algorithm, round robin algorithm, multi-level queue. So there are many algorithms for this CPU scheduling. So we would be starting with the first come first serve. So there are, we can see here with the example, it will be very clear to us. So there are three processes, P1, P2 and P3, and their CPU burst time are 24, let's suppose millisecond, 3 millisecond and 3 millisecond of P3. So when we are doing first come first serve scheduling, so the process will, suppose that it's process P1, it means it comes first and then P2 and then P3. So the process which comes first will be served first, means process will be arriving first, it will be getting CPU, it will be finishing its works, then only the P2 will be getting the CPU. When P2 will be getting, finishing its work, then P3 will be getting the CPU. So this is non-preemptive, and suppose we would be solving this problem with the help of Gantt chart. So this chart is known as, we can see this chart is known as Gantt chart, where we are showing all the processes and the timing it will, and the CPU burst time it will take. So suppose that the process arrive in the order P1, P2, P3, and the Gantt chart for the schedule is, let's suppose this is a Gantt chart G. So how can we calculate the waiting time of any process like P1, P2 and P3? What are the different waiting times for these processes? So waiting time P1 we are going to calculate. So at time 0, let's suppose P1 is at time 0 and CPU is scheduled to P1. So for CPU it has waiting time is 0. It arrives and it has taken CPU. So it means its waiting time is for P1, the waiting time is 0. Now coming to the next P2. So P2 has arrived, but because CPU was already allocated to P1, so it was waiting for 24 millisecond. जब तक P1 ने अपना काम किया है, तब तक P2 was waiting for that. So we can see here on time 24 millisecond when P1 has freed the CPU, then P2, then this CPU is scheduled to P2. Now it will start working, and for 3 millisecond it will work. So 24 plus 3 at 27 millisecond time it will be freed the CPU. P2 will free the CPU, and then the CPU will be located to P3. And the burst time for P3 का काम 3 मिलीसेकंड का है, तो 27 plus 3 that is 30 millisecond. So 30 millisecond पे P3 will free the CPU. So we can see here 0 is the waiting time for P1. For P2 it is 24 millisecond, after 24 millisecond it has got the CPU, and for P3 the waiting time is 27, right? And when we are going to get the average waiting time of all these processes, so we can calculate 0 waiting time of P1, 24 waiting time of P2, and then 27 waiting time of P3. Total number of programs was 3. So so we can find 51, and that is 17. So 17 millisecond. We can see here the average waiting time is 17 millisecond when we are using first come first serve scheduling algorithm. So when we are doing the same question, similar question with different algorithm, and the average waiting time will be reduced, so this is the benefit for the system. So maximum utilization, CPU maximum utilization is required, as well as average waiting time is good. Average waiting time should be minimum. So now coming to the next, that is, suppose the process arrive in the order. Now the process P2 will arrive first. Same in FCFS, we can see P2 will arrive first, then P3 will arrive, and then at the end P1 arrives. So we can see here P2 is arrived at 0 millisecond, P3 arrives at 3 millisecond. So P2, P3, P1 arrive at 0 millisecond, right? At the start, these all arrived, and we can see in the last slide. So P2 first come and it has done 3 millisecond work. So because इसका काम जो था सिर्फ 3 millisecond का था, so at 3 millisecond it has vacated the CPU. Then P3 arrived. Then the CPU is scheduled to P3. You can see here P3, the burst time was 3 millisecond. So after 3 plus 3 millisecond it has done its work, and at 6 millisecond it has given the CPU. Now coming to the third pick arrival है P1 का, so P1 will start the work at 6 millisecond and 27 milliseconds. So 6 plus 27. So it will finish its work, right, at 30 millisecond. You can see here, right? Then coming to the waiting time. So waiting time for P1. So P1 waiting time of P1, waiting time of P2, and waiting time of P3 we can find. How can we find the waiting time of all these three? So P2 arrive, so P2 का यहाँ पे अपना waiting time हुआ, P2 arrive करता है और इसे CPU मिल जाता है, तो P2 को इस टाइम पे वेट नहीं करना पड़ा है, तो इसका अराइविंग वेटिंग टाइम 0 हो गया. फिर P3 को मिलता है और P3 को सिर्फ 3 मिलीसेकंड के बाद मिल जाता है, तो इसका वेटिंग टाइम जो है वो 3 हो गया. एंड P1 को सबसे लास्ट में मिलता है, एंड वी कैन सी हियर P1 को 6 मिलीसेकंड वेट करना पड़ा है. सो नाउ वी कैन सी द एवरेज वेटिंग टाइम इफ वी वांट टू कैलकुलेट. सो 0 P2 के लिए, 3 के लिए वेटिंग टाइम रहा है 3, और P1 के लिए वेटिंग टाइम रहा है 6. सो नाउ वी कैन सी बाय 3, 9 by 3. So only 3 millisecond was the average waiting time. So we can see here how it arrives and how the CPU is given to. So first come first serve. So we are not seeing the CPU burst time. According to CPU burst time, if we have given the P2 and then P3, so the waiting time for this P1 was very less. That is why the average waiting time is very less. But in first come first serve, we are seeing only the first one arrives, and we would be giving the CPU to the first one. So just because of that, many times we can see the average waiting time will be very large. So this is the problem of first come first serve, and this problem is known as conveyor effect, where short process behind long process. So short process will wait for long time for the just because waiting for the CPU, and that is CPU is already acquired by the long process. So this is the problem, and the problem is very famous problem, that is conveyor effect, in which the long process is waiting according to its own CPU burst, long CPU burst, and it is and short process like 3 millisecond work is waiting for 27 milliseconds. So it is the problem. So because we have seen the problem that a short process is waiting for the completion of long process, so it takes average waiting time high. So in that case, we can see the another algorithm, that is shortest job first. So shortest job first is just like where we see the CPU burst time, and जिसका भी CPU burst time जो होगा वो shortest होगा. The one having shortest CPU burst time, CPU will be scheduled to that only. So this is where they associate with each process the length of the CPU burst, next CPU burst. So use these lengths to schedule the process with the shortest time. So SJF is very optimal because you can see the average waiting time can be reduced, gives minimum average waiting time for a given set of process, but the difficulty is knowing the length of the next CPU burst. So it is very easy to get the average waiting time down with the help of shortest job first, but the only problem is associated here is how to get the length of the next CPU request. So this is the problem associated with this algorithm. So we can see here, so there are 4 processes P1, P2, P3, P4, and their burst times are given 6, 8, 7, 3. So we can get the average waiting time with the same way. So the shortest we can see in this algorithm, we can see the CPU burst time 6, 8, 7, 3. The shortest length of the burst time you can see is of P4. So P4 will be getting the CPU first, then 6. So the P1 will be getting next, and then P3 will be getting according to the burst time, and then at the end, because its burst time is highest, so it will be getting at the end. So in the shortest job first, we can see the P4 will work its work for 3 millisecond, and then at 3 millisecond it will be given to CPU will be given to second 6 millisecond for C1. P1 will be getting second में, third P3 will be getting for 7 milliseconds, and then fourth for 8 millisecond, 16 plus 8. So we can see here 3 millisecond burst time, and after 3 millisecond P4 has freed the CPU, and then 6 millisecond, and after 3 plus 6, 9, it has freed, then 9 plus 7 millisecond, 16, it has freed at 16, and then 8 millisecond, so 16 plus 8, 24 पे P2 का काम finish हो जाता है. So when we are going to get the average waiting time, तो P4 को कितना वेट करना पड़ा है 0 प्लस P1 को देखते हैं कितना वेट करना पड़ा है 3 प्लस P3 को कितना वेट करना पड़ा है 9, 0 प्लस 3 प्लस 9 प्लस P2 को 16. So we can get 7 millisecond will be the average time, and we can see it. We can solve it with the first come first serve also. So we will be finding the average waiting time is very low in compare with the FCFS, but the only problem associated with this, how to take the next length of the next CPU burst. So now coming to the next example of shortest remaining time first. So now we add the concept of varying arrival time and preemption to the analysis. So in this algorithm where we find the sum problem, how to get, we are now associating with the, so in SJF the priority was shortest. Here we are giving the arrival time, I mean like when the process is arrived and their burst time. So in the prior algorithm, in the SJF, we considered that every process is arrived at the same time, and then we have at 0 time, and then we have given with the burst time, and then we have solved the problem with the SJF Gantt chart. Now, in the shortest remaining time first, so this is shortest remaining time first. So we will be seeing shortest job we will considering, but in any time, if we are going to preempt the CPU from the running process, then when it will be getting and how the process will be going on, we can see here. So P1 arrive at 0. So at 0 time, we were given with only one process. We can see here with example, it will be very clear, shortest remaining time first and how it is different from SJF. So we can see here at P1 time, only one process, sorry, at 0 time, P1, only one process P1 was there and the burst time was 8. So the CPU is given to P1. But at time 1, you can see here, there is another process, जिसका burst time जो है वो 4 है. So, as because the shortest job having its priority here, so now at time 1, we do have two processes with burst time 8 and 4. So, which one is shorter? This P2 is shorter. So, CPU will be taken by P1 and given to P2. So, now after 1 millisecond, the P1 will be going into waiting state, right? Now P2 is running. So at 2 millisecond, we can see another process P3 has arrived here. But when we are comparing the CPU burst time, this CPU burst time is higher than this. So there is no issue, P2 will execute. So at time 3, we can see P2 has its, P2 at time 3, P2 will compare its work 4 and 5. But the problem is P2 has already completed its 2 milliseconds. So only 2 millisecond work is left and here 5 milliseconds. So we can see, we can compare. So we can see here, and this one is the shortest. So P2 will complete, P2 अब अपना काम complete करेगा and then will free the CPU at 4 plus 1, 5 millisecond पे ये आपको free कर देगा. अब P1 का काम बच रहा है 7 millisecond का, P3 है 9 और P4. तो सबसे छोटा काम अभी जो दिख रहा है वो P4 का दिख रहा है. तो CPU will be given to P4 and P4 will execute its work for next 5 millisecond. So 5 plus 5, 10. It will complete its work. Now we can see, so 7 millisecond P1 and 9 millisecond P3, right? So we'll compare this. This one is the shortest job. This will be the shortest job. So we will compare this and we can see the shortest is P1. So P1 will execute its work for next 7 millisecond and then it will be coming to the last, that is P3, and it will complete its work on 26. So average waiting time we can calculate again. So as average waiting time for P1, P2, P3 and P4. तो इसके लिए कैसे waiting time निकालना होगा? P1 जब आया तो उसने 1 मिलीसेकंड का काम कर लिया है एंड देन P1 को वेट करना पड़ा है 10 मिलीसेकंड. तो 10 minus 1 is equal to 9 मिलीसेकंड वेट करना पड़ा इसको. देन फॉर P2 वी कैन सी, P2 आया है 1 मिलीसेकंड पे और P2 को उसी टाइम मिल गया है, तो P2 का 0 मिलीसेकंड. और फिर हम देखते हैं P3. तो P3 का 17 पे P3 को मिलता है और 17 से पहले P3 ने नहीं किया था और P3 खुद आ चुका था 2 मिलीसेकंड पे. तो 17 minus 2 यानी 15 मिलीसेकंड, 17 और ये आ चुका था 2 पे, तो 17 minus 2 मिलीसेकंड, इसको वेट करना पड़ा है 15 मिलीसेकंड. एंड द लास्ट वन, विच वन इज इट? सो इट इज जो आपका 5 P4 जो है जिसको 5 मिलीसेकंड पे मिला है और ये आया कितने था मिलीसेकंड पे था? P4 was arrived on 3 मिलीसेकंड. तो 5 मिलीसेकंड पे इसको CPU मिला है और ये आया था, अराइव हुआ था 3 मिलीसेकंड पे. सो वी कैन सी 2 मिलीसेकंड इज द वेटिंग टाइम. सो नाउ वी कैलकुलेट 9 plus 0 plus 15 plus 2 divided by 4 processes we do have. So 26 by 4 and that is the 6.5 millisecond. We can see here is the average waiting time. So here we can see the difference between SJF and between the shortest remaining time first. SJF assumes that every process arrive at 0 time, but in a shortest remaining time first, when job arrive, it compare करता है कि जो अभी अगर कोई job नहीं है तो बड़े job को ही दे देते हैं, and then we'll be comparing the job arrived at the next time and with the job running and the having lesser time, lesser CPU burst will be getting the CPU. So this is the difference between SJF and SRT first, and in the next video we will be discussing more about the differences between FCFS, SJF and SRJF and the different algorithms, their advantages and their disadvantages. For this video, thank you so much.